Okay, so ellipses we've looked at before. A little bit last year with some conics in Algebra 2, so let's do a quick little review here. Generally, your formula for an ellipse was your ideal formula, the one that you wanted to have, so you could see things quickly and easily, was x squared over some number plus y squared over some number equals 1. The reason that's a useful formula, if you go ahead and look at a specific example such as x squared over 10 plus y squared over 25 equals 1, you find your x and y intercepts just by visual inspection. You want to make this equal to 1, so x is plus or minus root 10, and you want to make this equal to 1 and x equal to 0 because then you get y plus or minus 5. So if you got your x and y intercepts for an ellipse that's centered at the origin, and these ellipses in the form of x squared over a number plus y squared over a number equals 1 are centered at the origin, you can quickly get your extreme points on your axes for the ellipse. You then also, last year, looked at finding the coordinates for your foci, and foci is the plural of focus. And your foci, you know, are on the major axis. You remember we're on the major axis. So in this case, if I look at my numbers here, 25 and 10, 25 is bigger. My major axis is going to have a length of 10, and that's going to be the y-axis, so my foci are on that vertical axis. The relationship, the coordinate you got for the two focal points was you looked at the numbers in the denominator here and you subtracted in the only way that makes sense. If you subtract 10 minus 25, you get a negative number. And I knew my number associated with the focus was the difference of the square root of the difference of those two numbers. So in this case, c squared, which is going to be my value associated with the focal points, is 25 minus 10, so c is plus or minus root 15. So then I can go ahead and then label 0 root 15 and 0 negative root 15 as the coordinates of my two focal points. So that's a little bit of review from what you did last year. You got some other vocab. You've got a minor axis, you got a major axis, you got your center, you got your focus points, you got your x and y intercepts. And you'll do a fair amount, of graphing ellipses in this section on ellipses. Now, a more interesting question would be, where do ellipses come from algebraically, and how perhaps can we view an ellipse as a transformation of another conic, namely a circle? And let's take a look at the definition real quickly first for an ellipse. If I have a set of points in a plane such that the distance, the sum of the distances to 2 points, 2 fixed points, and those are going to be my foci, foci 1 and foci 2. If I have the sum of those two distances is a constant, then if d1 plus d2 equals some constant, some number, then the set of points x, y that satisfy that are going to form an ellipse. And the example I showed on class today was that if you took a piece of string of a fixed length and tacked down the two ends, drew the string taut, and then went ahead and pulled the string taut and got all possible locations for where a point out there could go, that's when you're going to see your ellipse appearing. So again, a definition for an ellipse is the sum of two distances have to be a constant. Now, a couple things to notice. That string or that distance is going to have to be greater than f1 plus f2. If the distance is f1 plus f2, you can't pull the string taut anywhere to get a set of points x, y. So we should notice that. Depending on where those focal points are, an ellipse could be located in a whole bunch of places in a coordinate plane. Generally, we're locating our ellipse at the origin, and we're going to look at conics centered at the origin first before we start moving them around a bit. So that's our definition. So another way to look at an ellipse, in addition to the definition, is to consider if we have a circle, an ellipse, if it's elongated this way or elongated this way, an ellipse kind of looks like I took a circle and kind of squished it in or pulled it out. So when I think about squishing in and pulling out, I should be thinking about transformations of some sort. So suppose I have a circle, x squared plus y squared equals 25. What happens if I replace x with 2x, let's say, I know then that my graph is going to do what? If I replace x with 2x, my graph is going to be a horizontal shrink by a factor of 2. So think about if you take a circle and you horizontally shrink by a factor of 2, you're going to see perhaps a circle getting squished in where your y's are going to kind of stay the same, but you're squished in on each side. So let's go ahead and algebraically look at that and say if we replace x with 2x, we get 2x quantity squared plus y squared equals 25, 4x squared plus y squared equals 25. And now if I go ahead and put this into form of an ellipse, I'd like the right side of this equation to be 1. So if I divide everything by 25, I get 4x squared over 25 plus y squared over 25 equals 1. And I want to then say this is going to be x squared over 25 fourths plus y squared over 25 equals 1. I say, okay, where's that ellipse going to go? Well, so we're looking then at our y-intercepts clearly are still going to be 5 and negative 5 here because I want to make x is 0, so y is plus or minus 5. And then the question is, well, to make y 0, if I make y 0, then what would x have to be here to get x squared over 25 fourths equal to 1? And the answer is 5 halves squared, or negative 5 halves squared, over 25 fourths equals 1. So then my x-intercepts are 5 halves and negative 5 halves. 5 halves and negative 5 halves. And there's my ellipse. And again, what's happened? That 5, note on your original circle, you had a radius of 5, and now that x has come in from 5 to 5 halves and from negative 5 to negative 5 halves, indeed representing a horizontal shrink by a factor of 2. So an ellipse could be viewed perhaps as a horizontal shrink or stretch, or a vertical shrink or stretch of a circle. Now on page 226 in your text, they're going to derive the lovely formula, the x squared over a squared type of thing, plus y squared over b squared equals 1. They're going to derive that formula for you from, again, my general definition of an ellipse. Is they're going to give you, 2 focal points. They're going to put some general random point here, x, y, and they're going to go ahead with, this is C0, this is negative C0. They're going to go ahead and use the definition of letting D1 plus D2 equal some constant, and they're going to go ahead and derive the general formula for an ellipse. I'm not going to hold you to knowing that derivation, but I am going to hold you to understanding how you get from step to step in that derivation and appreciating it, because it goes from a geometric definition, the sum of two distances being a constant, to a lovely, very clean-looking equation for an ellipse that gives you information that allows you to graph that ellipse very quickly. Compare where the equation starts with 2 square roots from the geometric definition to where you end up with, which is a very clean, easy to look at expression that gives you x and y intercepts immediately, and with the relationship with a and b gives you where your foci are immediately. Now, when they set up that derivation for an equation for an ellipse, note that they set that distance, they let it be 2a, and that a turned out to be either the x-intercepts for the ellipse if the major axis was horizontal, or the y-intercepts for the ellipse, if the major axis were vertical. My question is, why does that constant distance, and remember, you're picking some point, random point here, x, y, such that that distance d1 plus that distance d2 is a constant. Why is it that that distance is always going to be, has to be, twice the length of, or actually it turns out to be the length of your major axis? And I'd like to take a minute and have you appreciate why that's true. And so here's the way we're going to work it. one of the points that's going to give me the sum of two distances being the same, one's here, this distance plus this distance equals that constant distance, but a special point which is going to give me that those two distances adding up to be the same are indeed the 2 points that are the x-intercepts. So if we take a look at one of them, let's take a look at this one right here. What are my distances back to the two foci? Here's one distance. What's the distance here back to this focus point here? Well, if this whole distance is A, and this distance is C, then this distance has to be A minus C. So one of my distances here going to this focus, D2 if you will, has to be an A minus C. How about the other distance? The other distance would be from here all the way over to here. Well, what distance is it from here all the way over to here? It's going to be A plus C. So I want to add up, that's going to be an A plus C. If I add up those two distances, what do I get? The C's will cancel and I'll get 2A. Well, again, that distance has to be a constant. So if it's going to be, for this specific point, if the distance from focus 1 plus the distance to focus 2 is going to be 2A, guess what? It's got to be 2A anywhere because that's my geometric definition. And I could kind of do the same thing here, working it over here. My distance from this focal point, from this point, the y-coordinate, or the y-intercept of the ellipse, there's one focal distance. That's going to be what? An A minus C. And the other focal distance is this one here. That's going to be an A plus a C. Add those two up and you're going to get 2A. So that distance that you're holding constant, that's the sum of the two focal lengths, distance to the focus, is going to be twice the length of your major axis. Twice the length of your, is the length of your major axis. It's twice the length of a semi-axis here, from out here too. So if your length here is 2A, then we know that D1 plus D2 is going to be 2A. So another example, let's suppose I want to graph, state the coordinates of the foci, state the lengths of major and minor axis, all that kind of stuff for a parabola or for an ellipse that shows up, say, in this form. I first note that I don't have a 1 over here, but that's pretty easy to solve. To get a 1, if you get a constant on one side, pretty easy to get yourself a 1, divide everything through by 24, so I get x squared over 8 plus y squared over 12 equals 24. So next question to ask is, where is my major axis? And 12 is greater than 8, so I know I'm going to have a major axis in the y-axis. And indeed, I draw down 12 is going to be, it's going to be 3 times 4, so I'm getting 2 root 3. So I'm looking at a y-intercept of plus or minus 2 root 3. And I then know that my x-intercepts, zeroing out y, x-intercepts is going to be, I want x squared to give me an 8, so that's going to be 2 root 2. And 2 root 2 clearly is smaller than 2 root 3. And so my ellipse is going to look something like this. I know my foci are on the y-axis, since my y-axis is the major axis, and my relationship between 8 and 12 to find that the coordinates of the foci would be c squared equals 12 minus 8, c squared equals 4, c equals plus or minus 2. And so then I can label the coordinates of my foci 0, negative 2, and 0, 2. So the center of the ellipse is, we're here centered at 0, 0, and the length of my minor axis is going to be 4 root 2, and the length of my major axis is going to be 4 root 3, and the coordinates of my foci are 0, 2, and 0, negative 2. So another type of problem that, again, it looks pretty similar to our general formula for an ellipse. We got a 1 here, that's good. We've got some x squareds and y squareds, and adding, that's good. But we don't have just an x squared or just a y squared in my numerator. So what I can do for that, and we've seen this earlier this year, is I can reciprocate that 4/3. 1 over 3/4 is 4/3. And I want to reciprocate the 5/36, and that's going to be 36/5. Note that if I simplify this expression, we get back to our original statement. But at this point now, I've got x squared over number plus y squared over number equals 1, and I can solve, and it's not a fun square root, it's not a pleasant square root to look at, but root 3 over 2 and 6 root 5 over 5 are going to be my numbers that are going to be my x and y intercepts, and I go from there. The arithmetic isn't fun. These numbers aren't like 36 and 100, and you just have to deal with the numbers.